Write the following in equivalent exponential form. So one very important technique when it comes to working with logarithms and solving logarithmic equations especially is being able to effectively change between exponential form and logarithmic form. And there's basically a mapping that you have to follow. So if I have y equals log base b of x, and I call this the log form of my equation, then the equivalent exponential form simply moves things around. The easiest thing to identify is the base because the base of the exponential and the base of the logarithm are generally very identifiable. It's just on the logarithm the number that is subscripted, or in the exponential the number that has an exponent. So the base of my exponential equation is b, and then I have to raise that to an exponent. And this is what you need to think about. The result of a logarithm is an exponent. So the exponent in the other form is this value y, and then the argument of the logarithm is the result of the exponential. So this is the mapping that tells us how to get from exponential form into log form and going the other direction as well. So if we have an equation that's in log form, say like in part A, so I have log base 6 of 36 equals 2. Then in exponential form, the base is this 6 right here, so this would be 6, and then we raise that to this value, which is the exponent, so to the second power, and that should result in the argument of the logarithm. So 6 to the second power is 36, so that checks out, and that's the equivalent exponential form. For part B, here we have log base 5 of 5 equals 1. So changing this into exponential form, the base is very readily seen to be as 5. It's just the number subscripted on the logarithm. The result of the logarithm is my exponent, and that's equal to the argument. So 5 to the first equals 5. In part C, it's looking like things are getting a little bit trickier. Here I have a base that's a square root, and the numbers here are a little bit larger, but I think the result's going to work out just the same. We just follow our mapping. The base of our exponential is the base of the logarithm. We raise it to the result of the logarithm, and that should be equal to the argument. If you wanted to check this one on your calculator, you absolutely could. I'll just go ahead and bring that up and show you how that could be done. So this would be the square root of 3, so let's put that in parentheses just to be certain the whole square root gets raised. Alright, so square root of 3 raised to the 8th power. And it might look like this should end up being some number with a long decimal that never repeats and whatever. But as we can see here, it does in fact equal 81. And the reason is when you square a square root, so if I take the square root of 3 and I square it, then that's going to get rid of the square root. So when you raise a square root to an even power, you're going to end up with integer values because the square root effectively cancels out. All right, then part D, I have log base 4 of 1/64 equals -3. To change this into exponential form, I identify the base, which is the number subscripted on the logarithm, raise that to the result of the logarithm, and that should be equal to the argument. And this probably helps shore up the concept of negative exponents, because when you have a negative exponent, what that means is you're in the numerator or possibly in the denominator, and you need to move that term to the other place. So this would go into the denominator, we make that a positive exponent, and then 4 to the third is 64. So 4 to the negative third power is equal to 1/64.